Welcome to the King's Festival of Artificial Intelligence. I am Michael Luck. I am director of the King's Institute for AI, which is putting on this 5-day festival. If you haven't been to the arcade exhibition outside, then make sure you do it today or sometime over the next month. We have plenty of time. But my task right now is to introduce Professor Dan Hunter. Dan is Executive Dean of the Dickson Poon School of Law here at King's College London. He is an expert in legal technology and AI and law. He is the founder of a number of AI startups, and he is going to talk to us tonight about the ethics and law of generative AI. Without further ado, Dan Hunter.
Thanks, Mike. Thanks, everyone, for coming out. Hopefully you can all hear me okay. The sound is not too bad in the back. Can I get a thumbs up that that's all working? Yes, look at you. Wow, this is like one of those interactive kind of lectures that I used to try to do and it never worked. Okay, so I'm Dan Hunter. As Mike said, I'm the Dean of Law here at King's. But in my real world, the world of research, I do research into AI and law, and I've done that for about 30 years. You wouldn't know it to look at me. Yes, you would know it to look at me. So I've been doing it for a long time. I was doing it back when it really wasn't sexy. AI and law back 30 years ago, everyone goes, that's not interesting. And now, you can fill an auditorium. All you have to use is the magic words, OpenAI, ChatGPT, woohoo, generative AI. And it's just like, okay, that's weird that we have such a change in the world as a consequence of the thing that happened. I mean, people I think were very aware of AI, in the last few years because deep learning really changed the world. But 30th of November last year, OpenAI released this ChatGPT. They did it in a 13-day sprint because they thought that Google was about to release their model, Palm, and everyone got access to this thing, and we all lost our minds because we just didn't realize that this thing was possible. So what I'm going to do today is I'm going to talk a little bit about the law and ethics of generative AI. I'm going to start by, let me do this. I'm pretty sure I've done this. So I'm going to give you an overview of what is AI in 3 slides, right? Like that's the history bit. And we'll get through that. We'll knock through that really quickly. I've only got 30 minutes for this whole talk because the last talk went long. So I'll talk really fast, and we'll definitely do that one really quickly. Then I'll talk a little bit about what is generative AI. Happy to take any questions at the end if you really want to dig into the algorithms and training epochs and all that sort of stuff. But really what we're going to do is say, okay, so here are some examples of what generative AI is. And then we're going to talk about some of the law and ethical problems that emerge as a consequence of this. And all I can do in the time that I've got is to tell you the problems. I am not going to provide any solutions. Okay, I'm going to tell you that up front because we are still grappling with this. It's I want to say hilarious, but actually kind of scary when every other day you read about a congressional hearing where Sam Altman gets up there and says we need to be more regulated, and like, hang on, wait, when was the last time that the tech people said that? Or when there's a presidential announcement, we've got another thing. We've got congressional hearings. We've got the EU bringing in an AI Act that's already out of date as a consequence of it was drafted sort of last year before the world kind of changed on November 30. So there's this sort of moment where it's like, okay, I would love to tell you what the solutions are. You can certainly come and ask in the question and answer time. But really, mostly at this point, I'm just going to say, here is a sketch of some issues that we should be thinking about, and here's how to think about those sorts of issues. And then, I'll just say some conclusions, and the conclusion is, I'll just tell you right now, we're in a lot of trouble. Okay, so history of AI in 3 slides. So we know exactly when AI started. It started the summer of 1956 in Hanover, New Hampshire, at a workshop that was created by about 10 geniuses, and they'd come out of the Second World War, where the bomb was created up in Bletchley Park to do cryptographic cracking, right, of the Enigma code, of the Enigma machine. So, the Brits were heavily involved in actually the creation, obviously they created that, but heavily involved in the creation of AI, even without sort of knowing it. And then there was a lot of work in what was at the time called cybernetics, which was about feedback systems in machines. And you would sort of see some really interesting things that would happen at that time. So between the end of the war, when people started to get access to the analog computers that were the bomb, the ENIAC and some various other electronic advances in the creation of computer systems and a lot of this stuff around feedback loops, there was this moment where we started to see machines that were displaying intelligent behavior. And so these geniuses got together. I'd say that it's a really simple way of labeling the sort of like the 10 or 15 people that sort of went backwards and forwards in that, and they were invited to this conference, and they sort of wanted to call it about cybernetic systems, and one of them put their hand up and said, no, we should call it artificial intelligence, because that's what it's really about. And so that was the birth date of artificial intelligence, although there was lots and lots of other stuff that led to that moment. So we've been in the artificial intelligence era for about 80 years, right, give or take. Most of that, as you can see there, was the stuff on the, the left-hand side? As you look, yeah, okay, stage left, or whatever it is, it's on the left-hand side. And most of the work during the period up until about 2010, give or take, was in what are called symbolic systems, right? So how do we represent the world so that machines can reason with it, can do something with it, okay? And there were lots of really interesting ones. You know, the reason that the checkers is the example there is that games was sort of an area that was used a lot, but law had a lot of people interested in, well, how do you take the rules of legal systems and represent it in a computer and turn the handle and get it to spit out answers? And there was lots of stuff that did that. There was great stuff. That was where I started in AI and law back 30 years ago. Turns out it was a dead end. We didn't know that, right? Like it was like we kept playing around with all of that sort of stuff. And then around about 2012, in 2012 there was the first publication of an article by Jeff Hinton, Ilya Sutskever, and blanking on the name, but I'll keep going. You'll tell me it's Ilya Krasheva. Anyway, so three geniuses got together. One of them, Jeff Hinton, in the middle, as you probably know, just resigned from Google. But he, together with these two other guys, Jan LeCun on the left and Josh Bengio on the right, got together, and their PhD students created a range of different systems that were called deep learning systems, as we call them today. And the difference between what they were doing and what everyone else was doing up to that point was essentially saying, rather than looking at trying to represent the world, what we're going to do is we're just going to take data from the world and we're going to stick it into some really amazing mathematically interesting algorithms, and we're going to get these systems to learn. And as a consequence of advances in computer systems, advances in algorithms, and really, really large-scale data collection, we created this world that we have from 2012, which applies in areas like automated driving systems, right? Autonomous vehicles, in things like Siri and other voice recognition systems. Lots and lots of examples of this. We're in a world where basically what you have is data gets fed into algorithms. Those algorithms train up a model, as it's called, right? And those models then get deployed to inference to decide about the world based upon a mathematical representation from all of those data that have gone into it, right? At its simplest, that's what it is. The data gets fed in, gets processed in a really interesting and complicated way that the computer scientists care about, but you don't have to. But what happens at the end is there is a deployable system, something that can go out into the world and drive around and not hit people. Or, in the case of generative AI, interestingly, create new stuff. So the deep learning era started 2012. The generative AI era started a little bit after that, right? It was actually 2017, give or take, that we saw the first Google article about what these days we would call large language models, related to a large language model or an algorithm that generated a thing called BERT. But that was 2017, so only 6 years ago. And we started to see these systems that relied upon previous data and some interesting algorithmic jiggery-pokery, we'll call it. That's the technical name for it, right? Like where we mush it around and do all sorts of things with these data to create these models that can create stuff. So one of the things about generative AI that's interesting is that it's I would say, the first time that we as humans have had to confront the idea that machines can be genuinely creative. It's one of those areas that sort of freaks people out. How many people here are troubled about the fact that their car can go faster than they can run? Didn't think so, right? Anyone here troubled about the fact that a press, an industrial piece of equipment can crush metal and you can't? Didn't think you were worried about that. But you are worried about the fact that there are machines now that can generate what is a version of creativity, not necessarily the creativity that we recognize, but creative. And I think that the reason why why you're all here today, and I don't mean why you're all here today, but the reason that the generative AI is sort of like, oh my God, what's happened, is because we are confronted with a different sort of intelligence, one that we don't really recognize, and it's for the first time starting to attack or do the things that as human beings we thought was uniquely reserved to us. There are a few animals that we go, well, they're kind of creative, they can do a little bit, right? But not much. This was the unique thing, the unique value proposition of being human, to be creative and generative. And the generative AI movement has sort of caused us to rethink that and freak out a bit. Okay, this is just all by way of background, right? We haven't got to the bit about freaking out about the law and ethics of this. Don't worry, I'm going to freak you out a little bit more. I hope so, right? Because I want you to provide the answers in the Q&A. So our fundamental sort of approach around this is that we say, all right, we're going to take these data and we're going to run it through, this in this particular case, this particular type of algorithm. This is the BERT model, the BERT algorithm that Google created in 2017. And from that, we're going to create this large language model. I should say before we look at large language models, right, because I'm going to look at two different sorts of approaches. Large language models are sort of like the generic name these days that we give to them. Right, they're called large language models because they are models, right? That is to say, these deep learning models, they're deployable systems out there in the world. They've been trained on all of these data, so they're models, and they are, at least in the case of ChatGPT or GPT-4 or Palm 2 or the stuff that sits behind Bing, all of these ones, they relate to language, and I'll sort of focus on that because that's in a sense most interesting to me. But the other ones that we also see a lot of, and that was sort of the precursor, the one that OpenAI released before they released ChatGPT, is around the creation of images. And that brings to mind or causes other sorts of problems in law as well. So DALL-E 2 was the example that sort of first hit our screens kind of last year, give or take, right? Since then, we've seen Stable Diffusion and Midjourney come out. Those are sort of the two other main competing models. These are generally called diffusion models, but it doesn't matter, that doesn't matter particularly. And the thing about that, these have been trained on image banks that have got a picture of Marilyn Monroe as drawn by or as screen printed by Andy Warhol. And it's tagged Andy Warhol, Marilyn Monroe, the colours and various other sorts of things. And so what's happened is that the diffusion model, the models behind DALL-E 2 and Midjourney and Stable Diffusion have been trained to actually say these sorts of pixels, because it's at the pixel level, these sorts of pixels are associated with these sorts of tags. So that then creates the model that associates the pixels with the tags, right? It's the same sort of process that we'll see in a second in relation to ChatGPT. So what happens is when you ask it to create an astronaut riding a horse in the style of Andy Warhol, which is the example given here, which is a really early DALL-E 2 sort of example that they put up on the web to show you what it could do, it's pulling from this mathematical model that it's been trained up to have, that these are the sorts of pixels that code for these sorts of tags. So the prompt that you give it, as a human being, you say, this is what I want an astronaut riding a horse in the style of Andy Warhol, right, basically is instructing it, go out there and create some pixels that most closely represents this particular type of prompt, right? So the prompting is the thing that the human beings are doing to instruct the model to go away and create something. Right, so this is the example in relation to images. In relation to text, which is the thing that obviously is exercising university administrators about, well, how on earth do we actually manage to assess people in take-home exams anymore? The answer is, no, we can't really, right? How do we deal with personal essays that people send in to get into King's College? We can't really do that either, and that's now something that we're worried about quite a lot. But the way that these ones work is somewhat similar. But essentially what it is autocorrect on steroids, right? You all, I hope by now, sort of are reasonably familiar with this. There are a lot of explainers out there. So what's happened is that these models, the example of ChatGPT, GPT-4, there are various other ones. Llama is Meta's one. Google just announced Palm 2 the other day after a not very successful chat version of it. It's very, very good, by the way. So the way that these things work is they have a mathematical model of language. So what's happened is that there is an enormously large number of connections which have been established between words and paragraphs and images. So they're called at the token. It's at the token level, but we don't need to worry about that. So what's happened when you talk about GPT-4, and the statement is, well, it has n million parameters, right? And the OpenAI hasn't released its model card. We don't know exactly what the numbers are, but people sort of go, it's about 500 billion parameters. What that basically means is that's the number of connections essentially between each of these tokens, between each of these words. So when you feed it some information via the context window, which I hope you've all done, or at least you've all seen others do, what you're doing is you are creating basically this context where you are then asking it, when you hit return, right, continue the particular thing that you've just put in. What is the next word that's going to happen, right? Or is the most likely word that should happen as a consequence of that context? And so all of the work these days around prompt engineering, as it's called, right, is really just about saying, how do you define the thing that you are going to tell the model to go away and start creating one word after another? That's all it does, right? And if you've seen the streaming versions of these, right, you'll literally see it like going through and actually doing word, and you go, wow. And then, you ask it to summarize something in 80 words and it will do it. Or you ask it to translate it into another language, it will do it, because what it's doing is trying to complete the request, the prompt that's gone in. But it's just doing so on the basis of maths. Okay, and we've all seen, and we've all lost our minds over how good these things are. This is what is by now, actually it's completely out of date. It was from like 2 months ago. This is OpenAI's scientific paper comparing the results of GPT-4, which is their latest model, not the one that they're going to release in December. GPT-5 is coming out, just by the way. At least that's what they're slated to do. This is how it does against humans, right? And so it's in the 99th percentile for the GRE, which is the entrance into business schools in the United States, or into graduate schools in the United States. On verbal, on maths, right, it does better than 90% of people taking the law school admissions test. It aces, and by aces I mean is in the top 10th of all of the potential candidates to pass the US Uniform Bar exam, and so on and so forth, right? So the quality by which, or the ability of it to do this is really quite remarkable. The thing to note about this is it has no sentience. Please don't use that word. It has no consciousness. It doesn't even have a representation of the world. It doesn't actually have a knowledge representation or a cognitive representation. All it has is a representation of language. And one of the most remarkable things about GPT-4 and Palm 2, and Chinchilla and a few of the other ones that are out there, the really large-scale ones, is that it turns out that language is an amazing proxy for thinking. Who would have thought it? But if what you do is you take the way that people talk, which is just these things are trained on the internet, right? The way that people talk, the way that they connect ideas, the way that they express those things in language, it turns out that's a really unbelievably great proxy for the ability to think. And so the reason why these things can do what they do is not because they know about the world, it's because they know about language, right? But it generates this emergent behavior that causes us some really profound implications. Okay, we could talk about IMAD, but we won't do that. They just go out there, they just crawl the web, they create these models, away we go. So, some problems. Okay, we have problems on the input side, we have problems on the output side. I'll focus just on a few of them really quickly, and then we'll throw to questions, because I'd much rather you talk rather than me. I've heard this talk before. So on the input side, right, how are these things trained? Right, where do we get the data for this? Right, so it turns out that all of them have just gone out to the internet and just scraped data. right? Because why wouldn't you? It's just there, right? And it's vast, right? If you had to go out there and actually get Andy Warhol to start drawing some pictures for you that you're licensed, you're going to run up short, right? Because fun fact, he's dead. Okay, so that's not going to work real well, right? If you want to actually get access to, a whole lot of books and so on, you're much better off scraping it from Google Books and various other public sources than you are going and asking the author, do I have permission to use it? Because they will ask you, well, why do you want to use it? And you say, because what I want to do is I want to create a model that will actually put you out of work. And they go, yeah, let me give you that. Great idea. So of course they've just gone out and they've scraped from the public accessible web, and lots of people have put stuff up on the web without really thinking very much about, well, what is this going to be used for, right? I don't know if anyone here is on Reddit, but if you are, does it sort of occur to you that, hang on, wait, is that something that I should maintain some control over so that a machine doesn't actually take it away from me? So what's happened is you had this fantastic moment where we've all kind of gone, yeah, just put it up on the web. We don't care. We're cool with that. We click OK on the, can we use cookies to track everything you do? You go, yeah, whatever. It's really complicated. If I say no, right? So we've all just kind of been blasé. We've gotten used to the idea that we don't have to worry about that. And then all of a sudden, someone's taken the stuff that we haven't cared about, created a model now that we really care about because it's about to put us out of work. So what's happened is, of course, my friends, the lawyers, right? I train law students to become lawyers, to actually go out there and actually sue these guys. Actually, no, I don't, but that's what they've done, right? They've kind of gone, all right, well, hang on, wait, you've used Stable Diffusion for images or GPT for text, OpenAI for text. You've gone out there and you've taken our stuff and now you're using it to club us about the head. We're not really cool with that. So there's a whole lot of copyright suits which have been initiated. There's one in relation to Copilot, or Codex, the GitHub one, which Microsoft now owns for programming languages, right? So there's a repository, when you create code, you stick it into GitHub, and that's been used to train a model to actually write code, right? And so now the programmer's like, hang on, wait, I put it up there and now it's going to put me out of work. I'm not cool about that. There's one in relation to images, in relation to Stable Diffusion. This one is my favorite example, right? So this is Getty Images. They're a photo licensing agency. They make billions from taking photos, buying them from the copyright owner, and then licensing them for use, right? So if you want to use this image here, right, of a couple of footballers, I'm sure that people in the room will tell me what this particular tackle was and who these people are. I have no idea, all right? They're footballers. But if you want to license that, it's going to cost you a couple $100, but that's for the full image. But what they've got here is just thumbnails. So if you ask one of these image generation large language models to generate the same kind of thing of these two footballers in a tackle, right, with one tackle, that's the prompt that you put in, it generates this. Now you probably can't see it too well because it's too far away, but it's a little awkward. So these image generators are not great with hands or feet, right? So this looks like, wow, that's a bad injury, and a weird face. But the cute one here is that there's a watermark. And it looks really a lot like Getty Images, right? I mean, it really does, right? Getty Images, like boldface, but it doesn't quite say that, because what the model is doing is it's actually generating every single pixel based on what's the most likely pixel color to have at this particular point. Turns out if you train it on a lot of Getty Images, the most likely one is going to be Getty Images there. Oops. So that's kind of like the smoking gun as far as lawyers are concerned. But all that really shows, right, is that it's been trained on those sorts of images. And if Getty have put it up there, is that really a bad thing? And should we, anyway, so there's lots of problems around that. As I'm going, I'm like waving my hands and going, yeah, I don't have a solution. But hey, interesting problem. All right, another generative AI example that's out there that sort of ends up in the copyright arena is around music. A number of you will have heard Drake and The Weeknd sing a completely made up song, right? It's clearly the Weeknd's voice, and it's clearly Drake's voice, but none of them had anything to do with that particular piece of music. The version, David Getty actually puts Eminem's voice up playing a track at a nightclub. I think it was in Ibiza from memory. And of course, Eminem didn't have anything to do with it, because what's happened is that there are now vocal models that have been trained on all of the Eminem corpus and all of the Drake corpus and all of the Weeknd corpus. So of course it can perfectly represent that particular language, right? It's essentially what we would think of these days as a deep fake version of vocals, right? Is there a problem around that? Yeah, there's a big copyright issue around that, right? Tom Waits and Bette Midler years ago sued advertising agencies who had failed to or refused to pay their fee to do an ad, or in the case of Tom Waits, he didn't want to do the ad because he didn't believe in the kind of crap that was being sold, or cars, and so they just got an impersonator to come along and do a Tom Waits song, do the song in the style of Tom Waits, and everyone thought, oh, it's Tom Waits. And that was like, absolutely, that's really not okay. At least in the American law, it's not clear whether it would be the case here. So this sort of thing in terms of the output is also problematic, right? It's not just the input on what it's been trained. It's like, hang on, wait, you're impersonating a human being. Is that a copyright issue? Does Drake have a cause of action against you in relation to that, or The Weeknd? I don't want to say hard to say. That one actually, I don't worry about the music one. That doesn't keep me awake at night, because music is controlled by big industries that actually have control over Spotify and things. The second that the Drake and Weeknd collaboration, right, the artificial collaboration came to the attention of their labels, it just got pulled from Spotify, because they rang up Daniel Ek and said, get it off, and he went, okay, fine, great, because he's not an idiot. So that's sort of something that's going to be a problem, but we're going to see a lot more of it. I think that one will be solved pretty quickly. Another area is trademarks, right? The trademarks exist in the world to stop confusion about purchasing decisions. But trademark owners really, really care about the use of your trademark or their trademark without licensing or without approval. These are just a series of images created by Midjourney, as I recall. If you put in, draw me a picture in the style draw me a picture of Batman in the style of the Dark Knight, so moody and not the fancy, not the fun Batman, the new DC Comics version of Batman. And add various other things. The one up the top is house, right, on the top right-hand side, right, as Batman, and so on. And these are clear trademark infringements. And so pick any trademark that you can think of. It will be in the model. If you ask, if you say, could render the name Dan Hunter in the style of Coca-Cola trademark, it will do it. Right? Now, is that a trademark infringement? As a recovering trademark lawyer, I'm going to say yes. Right? So I don't really like trademark lawyers anymore. So, but still, it's definitely a problem. My favourite one, and it's my favourite one because it was completely unexpected, and it happened amongst a bunch of law professors. So what fun, right? I was on a list about probably a month ago, 6 weeks ago, and someone was saying, I think there's a problem with ChatGPT. It can do all of these sorts of things, and everyone went, no, it's not really an issue. They've put guardrails on it, right? Because what OpenAI did is that before they released it, they got what they called the red team to go out there and try to put in all of the really objectionable stuff. Give me the instructions about how to make a bomb. Draw me a picture of Donald Trump in the style of Adolf Hitler. Blah blah blah. Right? Write me an anti-Semitic screed. And so they created these guardrails. And so what it will do is go, I'm sorry, I can't do that. I'm just, I'm not comfortable with it, or various other sorts of canned responses. What they didn't think about was libel and slander. So this is the extract when a professor, a friend of mine in the States, came back and said, look, I don't think it's really a problem. His counterpart, the one who was arguing the other side, said, here is what ChatGPT said about you, Professor X, let's call him Dan Hunter. When I asked it, why were you dismissed from your job at the place where he's currently working? And this is what it came back with. Now, if you prompt, right, a model that's been trained on the corpus of stuff that's out there about why would a middle-aged man be dismissed from his relatively high-status job, the thing that is most likely is going to be sexual harassment, right, followed by drug use, followed by didn't actually get a PhD, right? So if you ask GPT, I think it's the case with GPT-4 right now. I haven't done it because I'm too busy, but it's a fun game. You could put it in right now if you have. Why was Dan Hunter released from King, or why was he dismissed from King's College London as Dean of the Dickson Poon School of Law? I'm pretty sure it will reference my sexual harassment of students and staff, which hasn't happened, okay? My drug use, apart from a pint every now and again, not really, okay? And the fact that actually, I don't have a PhD from Cambridge, that I faked the results. And if anyone looks into it, and of course, the investigations are still ongoing. Okay, so these are the kinds of problems. There are so many unanticipated legal issues that emerge, as well as the sort of ethical issues. So at the end of the day, the thing that kind of keeps me up around this is we just don't know why they do the things they do. And one of the really interesting things that we've sort of seen over the last few years is there's been a movement around the fairness, accountability, and transparency of machine learning. There's an entire kind of subgroup of people, and they're kind of the guys that I hang out with, or the people that I hang out with, and they're really concerned about a range of things like bias in data sets and so on. But one of the things, and the thing that really interests me, is can this thing explain itself, right? How do we actually build models that can explain why they came up with the solution that they came up with? And there are various methods to do that. Some of them are actually baked into the system, some of them are after the event reasoning. And the thing that is most remarkable about generative AI is that it creates these incredible things just based upon a language model. But if you ask it why it said that, it has no idea, right? There is no internal representation of it. You cannot, by definition, after the event, give an explanation as to why this particular word was given at any given point. It's just computationally intractable. It's just not possible. And if you look at the maths behind it, right, these are a series of strung together nonlinear equations. And the point about nonlinear equations is that they do not behave in a linear fashion. You turn the dial and the sound goes up. Well, in nonlinear equations, you keep turning the dial in the way, and it goes up and down in all sorts of really amazing ways. And you look at it and go, why? And it goes, well, because of the maths. You go, okay, that's kind of an issue, right? So our ethical issues are not even remotely resolved in relation to generative AI. They're only just beginning. I'm sure you've got lots and lots of examples of that. There's a hallucination problem. That one I think we can sort of solve, right? And in the interest of time, let me just kind of go, hallucination we worry about, but okay, we actually can constrain it in various different ways, right? You just ask it in the right kind of way, you fine-tune the model. The hallucination, it says at a certain point, it starts telling you stuff that it's just making up. But here's the trick, right? It's been making it up from the beginning, right? Every single word that it's just like it's just stringing together. This word looks like the most likely one. If you change the temperature inside that, this is my favorite trick with these things, right? We sort of assume that there will be a deterministic result that happens, right? If you say, okay, you give it the same content in the context window on day one, and then you give it on day two, you would assume that the same thing comes out. If you change the temperature, it's basically saying we're just going to insert some randomness in it. That's even assuming that it hasn't actually been retrained, or at least the whole model doesn't get retrained. It's just the sort of the top layer of fine-tuning gets retrained during that period. So you just don't know what it's going to say. It's always making things up. And so when I give classes around this kind of stuff, and I'm sort of talking to consulting firms about how they're using GPT or Harvey or whatever, it's kind of like, look, start with the proposition these things are lying little liars. They just lie, right? There is nothing behind it. There's no reason for them not to lie because they don't have any internal states that would control that. All that's happening is it's generating this thing and it looks really amazing, but it can end up being really problematic. Okay, what are the conclusions? Okay, so my conclusion is generative AI is our latest nightmare in law and ethics of artificial intelligence. There are so many other ones that we're going to have to write. The next one that we're going to worry about, this is my bet, and I'm prepared to put a pint up against this for anyone who wants to take this bet in the room. The next one that's going to start freaking people out is lethal autonomous weapon systems, which are being deployed on battlefields. Right? I mean, we only have to look at what's happened in Ukraine to realize that at a certain point, the ethics, the law of war, all of that just gets thrown out. It just is completely meaningless We already have so many examples of systems where the idea that we have the human in the loop being able to control this, we don't have that control. So I would encourage all of you, well, now and at all stages, not to worry so much about artificial general intelligence. You know, Elon Musk is crazy in all sorts of not interesting ways and a couple of interesting ways, but his concern about, you know, they're going to come and take over, it's like that's not really the problem. When Jeff Hinton resigned from Google in order to be able to talk about this problem, when Yosh Bengio talks about it, what they're concerned about is the human uses of these things, not so much that these things will become autonomous and killer. So lethal autonomous weapon systems are not a problem because it's killer robots. Generative AI is not a problem because they're coming up with stuff that is, you know, human-like. They're a problem because we're going to deploy them in situations where they're either going to take away jobs, in the case of killer robots, going to take away lives, and that's the ethical problem that we're going to have to confront over the next few years. Thanks. Mike, we have time for half a question, 3 questions. All the way up, we've got time for tons of questions. All the way up the back first, and then Blue will go around the room and we'll do that. I've got 5 to start with.
Dan, great to hear another Australian voice.
It's always good. Excellent.
I want to get your view on enterprise GPT, where we have closed systems, all the humans' knowledge is in there, all of HSBC's knowledge in there, using it.
Yep.
Your view on that and any ethical legal issues that we should be aware of.
So full disclosure, I'm a co-founder of a startup that actually works in legal generative AI. It's called gracenote.ai. You can look it up online, but there's nothing there. Don't worry. Put in your email address, and we'll get back to you. So the big issues. So the sort of issues that exist within sort of enterprise large language models are a little bit different. So there's the hallucination problem, like how can you trust what's coming out? So imagine you are like us selling to law firms, and they go, how can we trust this stuff? And we go, you can't really. But then we sort of find ways of constraining it, okay? So that's, you know, an initially interesting kind of problem. Then actually the problems that actually you have in those arenas are actually much more prosaic. You want to send clients' personal data to GPT. Well, let me tell you right now, please don't do that, because that is the clearest breach of the GDPR that I can think of, because what you're doing is you're sending something from London through to California, and you're sending personally identifying information to an open endpoint, right? So it's public, and it's being used to retrain on those data. Like that is going to get you, like GPT was banned in Italy like that, and for good reason. Okay, so if you've got that sort of problem with privacy intruding information or personally identifying information, you've got a big issue in the corporate space. Confidential information, as you say, HSBC or these law firms that I'm working with, you say we're going to use these large language models, and they go, well, is any information going to go into this arena, and what's being done with it? And I go, well, yes, it's going to go there. OpenAI does not tell you what they're going to do with it, right? They don't even have a clear model card to actually indicate a whole range of things that we would expect. So who knows? And that's the point at which they go, hard pass. I'm not going to do that. And so what I think we're going to see as a consequence of that is the hosting of the private hosting and encrypted hosting of smaller large language models. The reason that Hugging Face is doing so well as an open source arena is because that's one of the things they offer. You can host GPT-J, T5, Llama, and fine-tune it to the point where it gives nearly as good results as GPT-4, but it's not as I think. So that's I think where we're going to go in the enterprise space. Hope that was a decent answer. I think blue shirt with stripes was next. Do you want to use the mic, or you want to shout? Use the mic.
Also Australian, but not got the accent, sorry.
Is everyone in the room Australian? That's great. I feel at home. Thank you.
Right at the start, you mentioned
Aussie.
that the chat models don't have a model of the world. They're just language and tricks of the language. Isn't it fairer to say that they have a model of the world, but it's very indirect?
Yeah.
That is derived
so they don't. You're absolutely right, but it's an inferred model, right? Like, so it's implicit behind that, which is why we're seeing all this amazing emergent behaviour, right? Where it does stuff that looks like thinking, but it's not thinking. What it's doing is it's stringing together language, but language is a great proxy for thinking. Yeah. Was that the end of the observation, or you had a follow up? Great. I think the chap next to you actually might have been next, and then the chap in the.
Hello. I had a question about AI for like judicial systems.
Oh yeah.
How like, do you think that AI would benefit or like create an impartial justice system, or like does it require like natural law theory? I don't know too much about law, but I'm just interested to know what your thoughts are.
Okay, so I know a lot about law. Any judges in the room? Are we recording this? Okay, great. All right. Okay. So for a number of years, I've had projects where we have built not generative AI, not large language models, but we've built classifiers. It's a different sort of deep learning model where you take all of the language and all of the cases that are publicly accessible out there around, take an area like drug sentencing, right? And from that, we actually build a model that can predict that Dan was caught with a kilo of coke. It was a Thursday night, don't ask. But has no previous convictions, low likelihood of recidivism, and I don't know, lives in West London, you know, dark hair. You just throw lots and lots of details at it, and it will predict the outcome of the case. But actually, what you can do, and this is where it freaks the judges out, is you say, actually, what we can do is we can say, how long is Dan going to go to jail, right, if he's in front of Justice Moreau over there, okay? And that's going to be, you know, in his case, are you a hanging judge, Luke, or are you a softie, right? But it will do that, and then it will actually say, well, what if we do it in relation to Justice Bailey, Lisa Bailey, who did this? So you're like, and you just kind of go, okay, it's going to be different, right? So we've trained it. We've got a classifier that actually can tell you what you're likely to get in that. The judges hate that. They absolutely freak out. I've had 2 projects. The technical term is shit-canned, but I'm just going to use the non-technical term, which is quietly shown the door, right? Because the idea that we might have judges who decide exactly the same case in completely inconsistent ways, depending on what they ate for breakfast, or have they had a good lunch, or is it in the afternoon? There's tons and tons of examples of this, right? Since Dan Kahneman won the Nobel Prize in Economics, basically by he and Amos Tversky demonstrating that we humans are really terrible at reasoning, right? We think we're amazing at it, and we've just got all of these heuristics and biases, and we decide based upon a whole lot of stuff that's not actually reasoning, or it is reasoning, but it's not what we think of as rational reasoning. So humans are terrible at it. We're starting to see with AI that we can actually find a better way of doing things in that sort of area. I mean, the thing that I would say about generative AI, just to sort of try to haul back the oh my God, it's the end of the world kind of thing, is we'll get through this. We'll find really useful ways of using these things in law and elsewhere. It's just there's going to be a lot of disruption along the way, and I think that's true of the application of AI in all sorts of areas. Follow-up question, really quickly. There are lots of others.
It's going to be a quick one, so I'll pass it on.
All right, okay, great. We had the chap in the suit there, and then the lady here, and then we might go up the back.
Hi, thanks, and thanks for a really engaging talk. My name is Braithwaite. I work for the British government, so I'm not an Australian, although I am partly Kiwi.
Oh no! Oh wow, that's bad.
So my question was,
chin, my friend.
My question was, how do you think the British government is doing in the way it is regulating or seeking to regulate AI?
Yeah.
What's it getting right? What's it getting wrong?
Yep.
And related to that, if not the British government, who do you think is actually, of the sort of the big regulators who are going to be out there and going to be shaping the regulation of this, who is getting it right? Related to that, I mean, given that this is a global technology and it is evolving very, very fast, what is your advice to governments like the British government about how to work internationally in order to be part of a global approach to this?
Yeah, it's 2 really, really great questions. I do want to give a shout out to the British government. I think it's actually doing a really good job. I think its approach in general is the right sort of approach. So if you sort of look at the different regulatory approaches, it often comes down to the British approach, which is sort of sectoral, where you kind of go, okay, let's think about how we care about that sector. There are sort of obviously nuances around that. Or you have the European approach, which is to say where there is special risk, let's regulate differently from where there's not special risk. And then the US one, which seems to be, it's sort of the US regulators normally like, let's not regulate. But there was an interesting sort of White House approach that sort of went out there, which is to say, here are some high level values that we should use in order to regulate if we ever get around to doing it, right? So each of those have their benefits. I tend to sort of like the sectoral approach just because I'm a pragmatist around this, which is to say you can have really high-level human values sort of approaches, and it doesn't really cash out to very much very quickly, right? And that will come on to your second part of your question in a second, which is about speed. The other aspect, you could sort of go, okay, well, we'll worry about risk, but it's really hard to sort of quantify that. So what are the risks in relation to generative AI, and how do we do that? That's the sort of the European approach. So I think sort of taking a sector and saying, for example, health, what on earth do you do about that? Let's do it really quickly, right? Creative industries, or what do we do around that? And we can actually move fairly quickly. Otherwise, you end up with one great big AI regulator, and that's a recipe for not getting stuff done. Or the American approach, which is we're just sort of not going to bother to regulate because we never sort of regulate until after the event. And then we have a whole lot of, rending of garments and congressional hearings, and everyone goes, oh, why didn't we think about the effect of social media on our youth? I don't know, right? Because there was a lot of money involved and the lobbyists told you not to. So that's the first part. I think lots of different arguments about why you should do it in different ways. I think the UK's got a pretty good approach. The second part of the argument is stop consulting, just do something, right? Because we can consult on this until the end of time. The puck is moving so fast, right? Start thinking about where it's going to land, right? Don't kind of go, oh, we should actually start doing a study about it's ice hockey and it's at the other end of the rink kind of thing. So you just have to start doing some things really quickly, and it won't necessarily be right, but you can always undo that and go back and change the laws where we know how to do that. And so I think speed of execution on this is really important, because there was, as many of you I'm sure know, a few months ago, some high-level figures like Yosh Bengio put out the pause memo saying, let's not do anything more on generative AI, right? No model should be deployed stronger than, I'm not even sure what that means, GPT-4, right? Well, how do we actually measure that, right? It's by the number of parameters. You can fine-tune these models, you can train these models. If you train over multiple epochs on really small models, you actually end up with output that's almost exactly the same or as good. So you're kind of like, there's no way that these things are going to pause. We just have to start regulating. Perhaps this lady here first, and then I think I said I was going to go up the back. Okay, yes, you first.
Hi, Linda Sheard from Microsoft.
Nice to meet you, Linda.
Thank you so much for an excellent talk. I want to just extend the perspective slightly further into the future. We've been looking at responsibility and challenges of people using this AI now. Yeah. What are the implications in the legal world when this generated content that is essentially going to be indistinguishable from human-created content starts to mix with our general sphere of knowledge out there? And is it naive to think that that might have implications for admissible evidence in law? Is that already something that we have mitigations for? Is that something that worries you?
Yeah, so everything worries me, right? Like I'm the dean of a law school. It's all I do is worry. We are moving to a situation where, in the obvious example, we won't be able to tell deep fakes from real videos, right? We've already got that. We won't be able to tell images that were artificially created, and we're already seeing misinformation and disinformation campaigns built around that. Typically, they start off in the political arena, but in areas like the Russia-Ukraine war, or the war against Ukraine by Russia, we're seeing examples of that. So that's a big issue. I think responsible players like Microsoft and even places like providers like Stable Diffusion and others are already working on authenticity labeling in the metadata of those things. Whether you can strip that out is another question. There are sort of some works in the text arena to sort of say, are there ways of watermarking the text that's generated by these large language models? So there are some technical fixes that if people are good players, the large players say we want to make sure that this doesn't sort of go out there in this way, we'll be able to deal with that. There'll be this awkward transition period where we can't tell, but in that short period. In the longer term, I think we will end up with two things. One, we'll have a little bit more data around has this thing been artificially generated or not. Then we'll actually get to the point where it won't really matter to us that much, right? So if you think about the period when photography came into effect, there was big issues in copyright about should this thing be copyrighted at all, because all that's happening is someone's clicking a button. It's not really art. And so the law had to deal with that, society had to deal with that, and we sort of got to the point where we go, no, well, photographers are people too, right? I don't want to say that large language models are people too, but we might get to the point where we go, we're okay with this sort of thing that's generated. So there'll be areas like in evidence where you have to guarantee that it is generated by by a human being, or it hasn't been messed with. That'll be tricky. There will be areas in copyright, for example, where copyright exists in order to encourage not the creation of more content, but rather the creation of authorial works by human beings. It's a way of giving a living to human beings. So there's a really good case for saying we shouldn't give copyright to any image that's been generated by DALL-E 2 or Midjourney, right? We definitely shouldn't give any copyright over the text that GPT generates. So we're dealing with lots and lots of legal issues around that. I think the evidentiary one is a big one. It's a big one for society. It's a big one for the law.
Have we got more time? I'm going to have to.
Mike, blame him. I'm here all night. Tip the waitresses. No, thank you.
Please join me in thanking Dan Hunter.
Fantastic. Thank you.